Good afternoon, kiddos. We are going to talk today about buoyancy. And buoyancy is a bit of a tricky concept, but it's not as tricky as you might think. It's connected to a couple others that we'll talk about right here. So here we go. If you look up the definition of buoyancy in a textbook, you're going to find something like this: the force exerted by a fluid. And it simply means that when you put an object into a fluid, the fluid is going to apply a force or pressure onto that object. That's pretty understandable. If you ever jumped into water, sometimes you feel like the pressure on your head, or as you go deeper, there's more pressure on you. Pretty simple. The density of the fluid greatly affects this, and the density of the object can also affect buoyancy. So let's look at that. Density is simply how packed the molecules are in a substance. So I have a box over here that has just a few circles in it. That is a low density substance. I have a box over here with a lot of circles or objects in it. That one is a high density substance. The low density things are just less packed. Could be the same material, just less full. The high density things, more packed, more full of molecules. This helps us determine if something is going to float or sink, depending on what fluid you put it in. So if we think back to that boat example, that boat is a certain density, whatever it is, and it's a certain weight. It's going to push down on the water. The water is going to push back on the boat, as are indicated by those arrows. If the water pushes up more than the boat pushes down, the boat will float. If the boat pushes down more than the object pushes, or the liquid, pushes up, the boat will sink. That would be a bad boat. That would be a rock. Or, yeah, just not good. So there are ways we can decide if things are going to float, sink, or kind of stay in the middle somewhere. And it's all related to how much force or the weight of the object is pushing against the fluid pushing back up. So you have 3 bottles in these pictures here. One is 1 pound, one is 9 pounds, and one is 12 pounds. Now the liquid is always pushing up with 10 pounds of force. Liquid doesn't change. The objects do. When the object is only pushing down with 1 pound of force, the object stays high in the water. Drop a sponge into water. You'll see that happens. Drop an object that's heavier, like 9 pounds. The water is still pushing up with 10 pounds of force, so the object will still float, but less high in the water. It'll sit a little lower. Think the end of the movie Titanic when Rose lets Jack go. Was that high or low in the water? Anyways. Then lastly, we have the 12-pound object. 12-pound object is pushing down with 12 pounds of force. The water is only pushing up with 10. Therefore, the object will sink. So objects can either float, sink, or kind of stay the same. And depending on the fluid you use, you can change the result. Like if I drop an object into one fluid, it may float, versus another one, it may sink. You can try that at home. All right, so I brought you out here to the hot tub to show you some examples of things that are positive and negatively buoyant. First example, goggles. Can anyone guess what you think they're going to be? Positively, negatively buoyant, or neutral? You can take them, drop them into water. They appear to sink. That means they are negatively buoyant. Right. Take something like a rubber ball. Positive, negative, or neutral buoyancy. Floats. Seems positively buoyant. Hockey puck. You guessed it, negatively buoyant. Last, garden trowel. I have no idea about this one. Negatively buoyant. So there you go. Positive, negative, neutral buoyancy. Oh, actually, I didn't have a neutral buoyancy one, but that's okay. You may have done this in a swimming pool, and if not, you should try next time you can get into one. It's really kind of neat. You have to take deep, long breaths, but we are filled with a bunch of air normally in our lungs, and that makes us a certain density. And most humans tend to float because of how dense we are. If you take a slow, big, deep breath out, you will notice your body starts to sink. That is because you're getting rid of that air and your density is going up. There's more packedness of molecules. There's less free space because your lungs are squishing together and the air has come out of you. It's actually kind of cool. Then when you take a deep breath in, you're going to come up. In fact, some kids or some people show that if you go cross-legged in the shallow end and you take a big deep breath out, you'll just sink to the bottom of the pool. It's pretty neat. Give it a try. What we're trying to understand is there's three levels of buoyancy: positive, negative, and neutral buoyancy. Positive buoyancy means you float, means the water is pushing, or the fluid you're in is pushing up more than you are pushing down. So you stay up floating. Neutral is somewhere in the middle. You would be not floating, not sinking, just kind of cruising along, like fish or the divers, which we'll talk about in a sec. Last one is negative buoyancy. If you push down or the object pushes down in water with a greater force than the liquid pushes up, it has negative buoyancy.
Here's some kitchen science. What we're going to do is we're going to look at, again, positive and negative buoyancy, and we're going to demonstrate that. Here I have a medicine dropper with some water in it. You can try this at home if you have one. I'm going to drop it into water, and it floats. That tells us that it's a certain density and that the liquid is pushing on it more than it is pushing down. Here's another one, and I'm going to drop it into water. We're going to see if anything different happens. This one sinks, so it has probably what? More or less water in it. That's right, it has more water in it. It has a higher density, it's pushing down with more force than the liquid is pushing up. One cool thing you can do is if you take the pop bottle, put the lid on it, you can squeeze the bottle, and this is going to cause all the fluid to be pushed around inside the container. And when we push that fluid, watch what happens. The Cartesian diver, as they're called, goes down. When I release the bottle, it comes back up. Can you explain why? When we squeeze it, we are compressing the air, and the water has to go somewhere. It's going to go two places, up to the top of the bottle, and it's going to push the space of air at the top of the medicine dropper to be compressed. More water is going to go into that medicine dropper, and then it's going to essentially cause it to sink. You can actually see it happening if you look carefully. So I invite you to try this at home. Take a medicine dropper, put a little water in it, and squeeze the bottle, and you'll see the water level inside the dropper rise, and then it will sink. If you get it just right, you can get it to kind of hang out in the middle, and there's neutral buoyancy.
Divers take advantage of this principle. So if you've ever looked at divers, they wear these belts on them. And the belts are designed to make the diver more dense. They need more force downwards because they don't want to sit on the surface of the water like a swimmer, because most humans are neutral buoyancy, so we float, and that's not good. Or we're positively buoyant, so we float, but we want to be somewhere neutral if we're scuba diving. So we add a certain amount of weight till we get to that point where we can just sort of sit and swim up or down. And that's sort of what we want to do. We want to swim up or down. We don't want to just sink to the bottom. So too much weight, if you put it on the belt, is going to cause you to sink. You'll become negatively buoyant. Not enough weight, you float to the top and you're just snorkeling. That's not what scuba divers want. They want to be in the water. So they add the weight to become a little bit more dense, so they're neutrally buoyant. Have you ever seen a hot air balloon? Fluids don't only have to be liquids. They can be gases. So the hot air balloon rises, it is becoming more positively buoyant. As it sinks, it's becoming more negatively buoyant. Take a helium balloon, same deal. It's positively buoyant. It's floating in air. It's rising up. The fluid it's in is pushing on it. So here's a question for you. We're in a fluid right now. We're in air. Are humans positively, negatively, or neutrally buoyant in air? Think about it. Yeah, we're negatively buoyant because we sink. Okay, most of us sink in air. I think we all do. Right, if you jump up, you're going to fall back down. So positive, negative, and neutral buoyancy. Buoyancy is just the force a fluid pushes up with. I think that's good. Make sense? Pretty straightforward. I'm going to intermingle some videos so you have some more examples. Go for it.